We gaze at the same moon our ancestors did, but do we really know it? For centuries, its face has told a story of serene, silent rock, but that story is incomplete. Hidden in the shadows and etched across its plains are puzzles that science still struggles to solve. These are lunar anomalies, strange features, and unexplained phenomena that defy our simplest explanations. From fleeting flashes of light to geological formations that look impossibly artificial, our celestial neighbor holds secrets we are only beginning to uncover. By the end of this journey, you will know 25 of the moon's deepest mysteries, each one a reminder that the familiar can be profoundly strange. What will you see the next time you look up at the night sky? The moon is not a static monument. It flickers. For hundreds of years, astronomers have recorded brief, mysterious lights dancing across its supposedly dead surface. These events are called Transient Lunar Phenomena, or TLPS. They manifest as sudden flashes of light, localized glows that can last for hours, or strange patches of color that appear and then vanish. The great astronomer Sir William Herschel, the man who discovered the planet Uranus, observed what he described as red, glowing spots on the lunar surface in the late 1700s. He even speculated, quite seriously, that they could be signs of lunar volcanoes or perhaps even activity from inhabitants. Modern telescopes and even Apollo astronauts have continued to log these strange occurrences. The proposed explanations are as varied as the events themselves. Some scientists point to outgassing, where trapped radioactive gases beneath the surface suddenly escape, disturbing the fine lunar dust and causing it to glow. Others suggest they are simply the visible flashes from meteorites striking the moon's surface at tremendous speeds. There is also a theory involving electrostatic activity, where charged dust particles levitate and spark in the harsh sunlight. Yet the frustrating truth is that no single theory comfortably explains every report. Some flashes are too bright, some glows last too long, and some color changes defy simple physics. This means one of humanity's oldest recorded lunar mysteries remains to this day utterly unresolved. While the moon flickers with transient lights, other mysteries are permanently etched into its skin. Scattered across the dark lunar plains are strange, bright, swirling patterns that look like cosmic fingerprints pressed into the dust. These are the lunar swirls, and one of the most famous is Reiner Gamma, a magnificent, curling, bright patch on the ocean of storms that resembles a delicate whirlpool frozen in time. Their beauty is matched only by their strangeness. First, these swirls are not related to the moon's topography at all. They are not hills or valleys or impact scars. They are simply patterns of brighter, highly reflective material lying on the surface, as if someone took a giant brush and painted a luminous design across the lunar ground. Second, and most crucially, these swirls possess highly unusual magnetic properties. The areas where they appear are local magnetic anomalies, creating small, protective bubbles in the moon's otherwise very weak magnetic field. This magnetic shield seems to be the key to their existence. The leading theory suggests that these magnetic bubbles deflect the constant, abrasive stream of particles from the sun, known as the solar wind. Over billions of years, the unprotected lunar soil darkens under this relentless bombardment, but the soil shielded beneath the swirls remains bright and fresh, preserving its original reflective color. But this just pushes the mystery one step back. How did these intense, localized magnetic fields form in the first place? One compelling idea points to ancient comet impacts. The theory proposes that when a comet struck the moon long ago, the tremendous heat and plasma from the impact could have magnetized the lunar crust in a swirling pattern, leaving behind this permanent, invisible shield. Another possibility involves subterranean lava tubes containing magnetic minerals. Yet, despite these elegant ideas, no theory perfectly fits every swirl's unique shape and magnetic signature. Their precise origin remains one of the Moon's most visually stunning and scientifically perplexing enigmas, a reminder that even the most beautiful patterns can hide deeply complex secrets. But the Moon's artistry extends beyond mere patterns of light and shadow. Some Apollo mission photographs appear to capture something far more startling, structures that defy any simple geological explanation. Among the most debated are two features known informally as the Shard and the Tower. The Shard, photographed during the Apollo 16 mission, looks like an impossibly tall, thin spire rising from the lunar surface, appearing almost translucent against the black sky. Not far away, another formation dubbed the Tower, or sometimes the Castle, presents a blocky, geometric silhouette that casts a remarkably long, straight shadow across the barren plain. To the human eye, they seem artificial, like the ruins of some ancient alien architecture. The scientific consensus, however, leans heavily toward a natural, if unusual, origin. Experts in planetary geology argue these are almost certainly tricks of perspective, light and shadow playing on jagged, irregular terrain. A low sun angle can stretch a small rock's shadow for miles, creating the illusion of a towering structure. The mind, especially when searching for patterns, is notoriously good at seeing familiar shapes in random chaos, a phenomenon known as pareidolia, like seeing a face in a cloud. Yet, the reason these images persist in the anomaly community is their perceived regularity. The edges of the tower appear suspiciously straight. The shard's proportions seem too slender and uniform to be a simple boulder. Proponents ask, could these be the eroded remnants of something else, perhaps natural glass formations forged by extreme heat, or even evidence of a long-vanished presence? While Occam's razor suggests they are rocks, the lingering doubt they inspire is a powerful testament to the Moon's ability to confuse and captivate us, presenting riddles that are, in the end, a battle between what our cameras record and what our minds believe. These strange spires on the lunar surface have a name, the Blair Cuspids. In 1966, NASA, a Lunar Orbiter 2 spacecraft, was mapping potential landing sites for the Apollo missions when its camera captured something startling in the Sea of Tranquility. The image revealed 8 slender, needle-like formations standing in stark relief against the smooth mare. They were tall, some estimated to be as high as a 5-story building, and they cast long, sharp, perfectly parallel shadows that stretched like dark fingers across the plain. Their arrangement was what truly captured imaginations. They appeared to stand in a precise geometric pattern, an alignment that felt deliberate rather than random. To many observers, the scene looked less like a natural rock formation and more like a row of monolithic structures, perhaps even the ruins of some ancient alien installation. The scientific explanation is far more terrestrial in nature. Geologists propose these are simply outcrops of exceptionally hard basalt rock, the remnants of volcanic activity from the Moon's distant past. They could be what are known as volcanic dikes, where molten rock forced its way up through cracks in the crust and then solidified into a much harder material than the surrounding terrain. Over eons, the softer material around them eroded away, worn down by the constant micrometeorite bombardment that acts like a slow sandblaster on the lunar surface, leaving these resilient spikes standing in solitary defiance. This process, called differential erosion, is common on Earth, creating features like the majestic stone spires in Monument Valley. Yet, the nagging question of their near-perfect alignment persists. Is it merely a fantastic coincidence of geology, a random grouping that happens to form a straight line from our specific vantage point? Or does their orderly placement hint at a different, more mysterious origin story, one written not by lava but by something else entirely? The Blair Cuspids stand silently in the Sea of Tranquility, a monument to either the power of natural forces or a puzzle we have yet to fully decipher. The search for strange structures does not end with the Cuspids. Another Apollo mission, Apollo 15, provided an image that became legendary in anomaly circles, the so-called moon spire. The photograph taken from the orbiting command module shows a thin, needle-like projection rising from the horizon near the mountain Mons Hadley Delta. Against the stark blackness of space, it appears as an impossibly slender column, estimated by some to be several miles high, casting a long, crisp shadow back toward the surface. It looked for all the world like a monolithic tower built by some advanced intelligence. The reality, while less sensational, is a perfect lesson in lunar perspective. Analysis by planetary scientists revealed this was not a free-standing tower at all. Instead, it is almost certainly a steep, narrow ridge or a sharp outcrop on a distant mountain, viewed from a very specific angle that compresses its dimensions and isolates it against the void of space. The low, grazing sunlight highlights its edge while plunging the connecting terrain into deep shadow, creating the powerful illusion of a solitary, impossible spire. It is a trick of light and vantage point, a celestial mirage made of solid rock. A similar trick of perception gave us the famous Lunar Bridge. In the early 1960s, astronomer and writer John J. O'Neill was studying the edge of the Mare Crisium through his telescope when he observed something astonishing. Stretching across a deep chasm, he reported seeing a colossal, perfectly formed arch, a natural bridge spanning an estimated 12 miles. He announced his discovery with great excitement, suggesting it was a geological wonder of unimaginable scale. Other observers soon trained their telescopes on the location, and while some confirmed seeing a bridge-like structure, others saw only a trick of the light across a jagged, broken landscape. The consensus that eventually emerged was that O'Neill had witnessed a rare alignment of mountain ridges and deep shadows. Two peaks on either side of a valley, illuminated from a specific angle, can create the unbroken silhouette of an arch, with the shadowed valley floor below completing the illusion of a span. There was no actual arch, no single piece of rock forming a bridge. It was a magnificent example of pareidolia on a planetary scale, where the human brain connects disparate points of light and dark into a familiar, impossible shape. So why, if these have been largely debunked as illusions, do they hold such power over our imagination? The answer lies in their audacity. They are not subtle. The moon spire looks deliberately crafted, a marker placed on the horizon. The lunar bridge seems like a purposeful structure, an artifact of engineering so vast it defies belief. They tap directly into a deep-seated human question: are we alone? In the silent, gray vastness of the moon, these features offered a shocking yes, a hint that someone or something might have been there before us. They represent a moment where the cosmos seemed to speak in a language of geometry and architecture, a language we instinctively understand. Even when science explains the trick, the emotional impact of that first glimpse remains, a testament to our endless hope of finding company in the great emptiness. And sometimes the most compelling mysteries are not about what is actually there, but about what we desperately wish to see. The moon's surface can play tricks on the eye, but its gravity holds far more concrete mysteries. Early in the lunar exploration program, NASA scientists encountered a perplexing problem. The orbits of their spacecraft, like the lunar orbiter probes, were behaving unpredictably. As these satellites passed over certain circular maria, the great dark planes we see from Earth, they would inexplicably speed up, dipping slightly lower in their path before returning to a normal trajectory on the other side. It was as if invisible hands were tugging them downward. This anomaly led to the discovery of mascons, a shorthand for mass concentrations. These are regions beneath the moon's surface where gravity is significantly stronger than the surrounding area. They are essentially massive, invisible lumps of extra density buried deep below the plains, warping the local gravitational field. Their locations are not random. The most powerful mascons lie directly beneath the circular maria, like Mare Imbrium and Mare Serenitatis, which are themselves the scars of cataclysmic asteroid impacts from billions of years ago. The leading theory paints a dramatic picture of the moon's violent youth. When a giant asteroid struck, it blasted out an enormous crater, fracturing the crust and allowing the hot, molten mantle below to well up into the gigantic hole. Over time, this vast sea of lava cooled and solidified, but this wasn't just any rock. The magma that rose was denser and heavier than the crustal material around it. This dense plug, now frozen in place beneath the smooth plain, is the mascon. It is a buried monument to an ancient catastrophe, a geological tombstone marking the site of an impact so powerful it reshaped the moon's very interior. Yet mysteries remain. The density distribution within these mascons isn't perfectly uniform, suggesting the lava pools may not have cooled evenly or that the impacts themselves left complex rubble piles deep underground. For modern missions, mascons are more than a curiosity, they are a navigational hazard. Precise landings, especially for crewed missions targeting specific scientific sites near these basins, require sophisticated computer models to counteract their gravitational tug. So while they may not be alien artifacts, mascons are a powerful reminder that the moon's true structure is hidden from view, its history written in the language of gravity, a force that continues to guide and challenge our journey there. Gravity shapes the moon from within, but its surface bears the scars of flowing forces from a different kind of fire. Cutting across the gray plains are deep, winding canyons known as lunar rills, and they are among the most dramatic and puzzling landscapes astronauts have ever witnessed. The Apollo 15 mission drove right up to the edge of one of the most famous Hadley Rill. From the rim, astronauts David Scott and James Irwin looked down into a chasm over 1,000 feet deep and almost a mile wide, a snaking riverbed of emptiness that stretched to the horizon. But this river never carried water. Lunar rills come in two main types, each telling a different part of the moon's volcanic story. The first are the sinuous rills like Hadley. These look exactly like dry, meandering riverbeds on Earth, complete with oxbow curves and tributaries. The consensus is that these are the ghosts of ancient lava flows. They could be the collapsed roofs of massive lava tubes, tunnels where molten rock once raced beneath the surface, or they could be channels carved directly into the ground by rivers of lava so vast they are almost unimaginable. The scale is what baffles scientists. To carve a channel the size of Hadley Rill, the lava flow would have had to be extraordinarily fluid and voluminous, possibly flowing for hundreds of miles. This suggests a kind of volcanic eruption on the young moon that we have no direct comparison for on Earth today. The second type are arcuate rills. These form sweeping, curved cracks often found bordering the large circular maria. These are tectonic features, giant stress fractures in the lunar crust. Think of the moon's surface as the skin on a pot of pudding that is slowly cooling and shrinking. As the massive lava seas in the basins cooled and contracted, they caused the surrounding crust to buckle and crack, creating these graceful, arc-shaped chasms. The enduring mystery tied to the sinuous rills is not just their past, but what might remain hidden below. If some rills are collapsed lava tubes, could sections of those ancient tunnels still be intact? The possibility of massive, cave-like lava tubes, some potentially large enough to house entire cities, is taken very seriously by planetary scientists. These subsurface caverns, shielded from cosmic radiation, wild temperature swings, and micrometeorite impacts, would be the perfect natural outposts for future human habitation. So these eerie, empty channels are more than just geological curiosities. They are clues to the moon's fiery temperament and might quite literally hold the key to our future there, offering ready-made shelters in a world with no air, a silent promise of sanctuary written in stone. The smooth plains of the Maria are not the only places where the moon seems to move. In 1956, a respected astronomer named Dinsmore Alter was conducting a routine photographic study of the large, complex crater Alphonsus. The images he captured that day would become legendary, recording one of the most visually arresting transient lunar phenomena ever documented. in a series of photographs taken over a short period, a strange, amorphous, misty patch appeared to creep across the crater's floor. It did not look like a flash or a pinpoint of light. Instead, it resembled a low-lying fog or a translucent wave of vapor, silently rolling over the stark lunar terrain before it gradually dissipated and vanished. Alter described it as a veiling of the surface details, a temporary obscuration that seemed to possess a fluid, almost purposeful motion. This event, now famously called the lunar wave, stands apart from other fleeting lights. Its scale was immense, covering a significant portion of the crater, and its behavior suggested a physical substance, not just a flash of energy. The most grounded explanation points again to outgassing. Alphonsus is known for its fracture lines and its historical association with TLP sightings. The theory suggests that a sudden release of trapped gas, perhaps radon from deep radioactive decay, could have erupted from a fissure. In the vacuum of the lunar surface, such a gas would expand rapidly, potentially carrying with it fine dust particles. This suspended cloud, illuminated by the sun, could create the exact appearance of a rolling, misty wave as it spread across the crater floor before the dust settled and the gas escaped into space. Some have even proposed it could be a form of electrostatic dust storm, where charged particles lift off the surface in a collective wave. Yet, the event's clarity and apparent cohesion have fueled more speculative ideas for decades. Could it have been a literal cloud, implying the brief, impossible presence of some volatile substance like water ice vaporizing in sunlight? The lunar wave remains a singular enigma, a ghostly ripple in the cosmic stillness that was captured just once with a clarity that refuses to be fully explained away. It is a reminder that some lunar mysteries are not just points of light, but phantom weather on a world with no atmosphere, a fleeting spectacle that challenges our very understanding of that airless, static landscape. The silent darkness of the moon's night side is regularly shattered by violence. While the transient phenomena we discussed earlier are mysterious glows, there is another class of flash that is definitively explained, yet still holds surprising secrets. These are lunar meteorite impact flashes, the brilliant, split-second explosions that occur when a meteoroid, often no larger than a pebble, slams into the moon at speeds exceeding 40,000 miles per hour. Unlike Earth, the moon has no protective atmosphere to burn up these incoming space rocks. They strike the barren surface directly, converting their immense kinetic energy into a sudden, blinding flash of heat and light. For centuries, these flashes were likely mistaken for other transient events, but today we have dedicated projects like NASA's Lunar Impact Monitoring Program and the European Space Agency's NELIOT, a system that uses powerful telescopes to watch for them. Their goal is practical: to map the frequency of these strikes and assess the hazard they might pose to future astronauts and habitats. The anomaly here is not the existence of the flashes, but their startling behavior. The monitoring networks have recorded some impacts that release far more energy than their estimated meteoroid size should allow. Imagine throwing a marble against a concrete wall and seeing the explosive power of a hand grenade. That is the scale of the discrepancy scientists are seeing. Some of these flashes are so bright they can be seen with backyard telescopes, suggesting impacts from objects much larger than the typical background population of tiny particles. This leads to a profound question: what exactly is hitting the moon? The current data suggests there may be a hidden population of small, yet dense and fast-moving, meteoroids in the Earth-Moon system that our current models do not fully account for. They could be fragments of asteroids with unusual composition, or they might be traveling at velocities higher than we predict. Each brilliant flash is not just a spectacle, it is a data point in a cosmic calculation, revealing that the space immediately around our world is more active and potentially more hazardous than we once believed. Every time one of these tiny bolts strikes the lunar surface, it illuminates a gap in our understanding of the very environment we must travel through to return there. While some flashes are violent and unpredictable, other luminous mysteries on the moon arrive with perfect punctuality. Among the most striking are the Lunar X and the Lunar V, two brilliant geometric symbols that appear not from any artificial source, but from the precise alignment of sunlight and shadow. For a few hours each month, just as the Terminator line, the boundary between lunar day and night sweeps across a specific region. An unmistakable letter X seems to be etched onto the moon's face. It is formed by the intersecting rims of the craters Blanchinus, Lacaille, and Purbach. When sunlight strikes this complex terrain at a very shallow angle, the raised ridges of these craters catch the light while the adjacent low areas remain in darkness. This interplay creates four distinct points of bright light that connect in our vision to form a perfect, shining X against the gray backdrop. Nearby, under similar lighting conditions, the rim of the crater Euclid can create a sharp, luminous V. These are not structures or alien markings, they are the ultimate celestial shadow play, a demonstration of how the stark, airless landscape of the moon can turn simple topography into breathtaking, transient art. The delightful paradox of the lunar X and V is that they are completely predictable. Astronomers can calculate their appearance down to the minute, and amateur astronomers around the world eagerly await these windows to observe and photograph them. Yet, to the unprepared eye catching a sudden glimpse through a telescope, their appearance is nothing short of miraculous. They look deliberate, a stark, glowing symbol placed upon the lunar surface. This makes them a perfect example of a solved anomaly. The mystery of their origin is gone, replaced by a clear understanding of orbital mechanics and solar geometry. But the sense of wonder they inspire is entirely intact. They remind us that the universe often creates its own art, and that the line between a profound mystery and a beautiful explanation can be as sharp as the shadow on a crater's rim. Our moon possesses a ghost of a magnetic field. Unlike Earth, with its powerful global dynamo generated by a churning molten core, the moon's overall magnetic field is almost non-existent, a faint whisper in the solar wind. This makes the discovery of localized magnetic anomalies all the more startling. Scattered across the lunar surface are pockets, some hundreds of miles across, where the magnetic field is hundreds of times stronger than the surrounding areas. These are not just subtle variations, they are intense, focused magnetic patches embedded in the crust like frozen fragments of a forgotten force. Their origin is a major puzzle. One leading theory points to catastrophic violence from the moon's youth. During the period of heavy bombardment over 4 billion years ago, the lunar surface was pummeled by enormous asteroids. Some of these impactors may have been rich in iron and other magnetic materials. When they struck at unimaginable speeds, the heat and pressure of the collision could have vaporized the asteroid and superheated the local lunar rock, creating a plasma soup. As this chaotic cloud of charged particles cooled and settled, the magnetic minerals within it could have aligned and solidified, imprinting a powerful, permanent magnetic signature onto that specific patch of crust. It is as if the asteroid's magnetic soul was stamped into the moon at the moment of its own destruction. Another compelling idea suggests these patches are not imported but native relics. They could be remnants of a much older, global magnetic field that the moon once possessed billions of years ago, when its core was still molten and active. As that global field decayed, these stronger patches might be the last surviving fragments, preserved because the crust in those specific locations contained highly magnetic minerals that locked the field in place as the rock cooled, creating magnetic fossils of a bygone lunar era. But the influence of these anomalies is not just a matter of scientific history, it actively shapes the lunar environment today. These magnetic patches create what scientists call mini-magnetospheres. Just as Earth's magnetic field deflects the solar wind, the constant stream of charged particles from the sun, these lunar anomalies create small, invisible bubbles of protection. They act like magnetic umbrellas, shielding the patch of soil directly beneath them from the relentless weathering of solar particles. This is where the connection to one of our earlier mysteries becomes clear. Many of those enigmatic, bright lunar swirls, like the beautiful Reiner Gamma, are located directly over these powerful magnetic anomalies. The leading theory is that the solar wind, over billions of years, darkens the lunar soil through a process called space weathering. But under the magnetic umbrella, the soil is protected. It remains bright and reflective, preserving its original color while the terrain around it darkens, painting those magnificent, swirling patterns with an invisible magnetic brush. So these hidden magnetic fields are not merely curiosities. They are active artists on the lunar canvas, sculpting the moon's appearance in ways we are only beginning to fully appreciate. One of the most intense magnetic ghosts on the moon swirls around its most prominent crater. Tycho, with its brilliant system of rays stretching thousands of miles, is the moon's freshest large scar, an impact perhaps only 100 million years old. But Tycho's true surprise lies beneath its shattered floor. Orbital measurements have revealed an exceptionally strong and highly localized magnetic field centered on the crater itself, a powerful anomaly that seems to be a direct product of the cataclysm that formed it. This is not a relic from the moon's ancient past, but a magnetic signature stamped into the crust in a single, violent instant. The leading theory is as elegant as it is dramatic. The object that carved out Tycho was not a typical rocky asteroid. Scientists believe it was likely a metallic asteroid, a dense, iron-rich body from the heart of a shattered protoplanet. When this cosmic cannonball struck the lunar surface at tens of thousands of miles per hour, the physics became almost unimaginable. The impact did not just excavate a crater, it generated temperatures hotter than the surface of the sun and pressures exceeding those deep within the Earth. In that apocalyptic moment, the metallic impactor and a portion of the lunar target rock were completely vaporized, creating a superheated, ionized plasma, a soup of charged particles expanding in a fireball. As this chaotic cloud began to cool and the electrons and ions recombined, the presence of all that molten magnetic iron acted like a dynamo. The swirling motions within the cooling plasma could have generated a powerful, temporary magnetic field. Then, as the melted rock splashed across the crater floor and began to solidify, minerals within it, particularly iron, aligned with that fleeting field and froze it in place. The result is the Tycho magnetic anomaly, a fossilized magnetic snapshot of the impact's final microseconds. This makes Tycho a unique laboratory. By studying the strength and structure of this magnetic patch, planetary scientists can peer back in time to infer the composition of the impactor itself. It provides tangible evidence that the solar system's early bombardment included these dense, metallic bodies, and it offers crucial insights into the complex, energetic processes that can generate magnetic fields without a planetary core. The crater's brilliant rays are what we see, but its hidden magnetic heart tells the deeper story of the bullet that created it, a story written not in light but in force. A world without air should be a world without a sky, electrically speaking. The moon's atmosphere is so vanishingly thin it is called an exosphere, where atoms are so sparse they rarely ever collide. This means the moon should have no ionosphere to speak of, no permanent layer of charged particles high above its surface like the one that envelops our own planet. Yet, this seemingly solid fact has been challenged by strange readings from space. During radio occultation experiments, where a spacecraft passes behind the moon and its radio signal cuts through the lunar environment, scientists have occasionally detected a curious distortion. The signal would bend and delay in a way that suggested it was passing through a faint but distinct shell of ionized particles, a ghostly lunar ionosphere. The detections were not consistent, sometimes showing up strongly and other times not at all, which immediately cast doubt and sparked controversy. How could an airless body create and sustain such a layer? One compelling idea points to a dynamic process happening right at the surface. the relentless solar wind, a stream of charged particles from the sun, constantly bombards the lunar soil. When these particles strike, they can knock other particles loose from the dust grains in a process called sputtering. This could create a temporary, wavering cloud of ionized atoms just above the ground, a kind of electrical haze lifted by the sun's energy. Another source could be those mysterious outgassing events we discussed earlier. If pockets of radioactive gas like radon are occasionally released from the interior, the sun's ultraviolet radiation could quickly ionize that gas, creating a localized, temporary bubble of charged particles that would register on a passing spacecraft's instruments before dissipating into space. The sporadic nature of the detection supports these theories, suggesting the lunar ionosphere is not a permanent structure but a fleeting phenomenon, appearing and vanishing with the release of gas or the changing angle of solar bombardment. For some scientists, the data remains controversial, possibly explained by instrument artifacts or the complex plasma environment surrounding the moon itself. But if it is real, this phantom ionosphere reveals a moon that is electrically active in ways we never anticipated, a place where the very dust underfoot can be stirred into a temporary, electrified sky. The moon's hidden magnetic fields shape its surface, but sometimes the greatest mysteries involve objects we placed there ourselves. In 1970, the Soviet Union's Luna 17 mission achieved a quiet milestone, gently depositing the Lunokhod 1 rover onto the Sea of Rains. This 8-wheeled robotic explorer, the first remote-controlled vehicle on another world, carried a sophisticated scientific instrument, a French-built laser reflector array. This device was not for looking out, but for looking back. It was designed to be a permanent, precise target for lasers fired from Earth. By timing the light's round trip, scientists could measure the Earth-Moon distance down to the millimeter, testing gravity and even probing the Moon's interior structure. The rover operated for nearly a year, then fell silent. With its exact final parking spot unknown, the reflector, a small silver cube on a remote world, was effectively lost. For nearly 4 decades, it was a ghost in the scientific machinery, a tool of immense potential that had simply vanished into the gray vastness. The anomaly was its disappearance, a man-made landmark swallowed by the very landscape it was meant to measure. Then, in 2010, a detective story unfolded in orbit. Scientists working with images from NAS, a Lunar Reconnaissance Orbiter, or LRO, were meticulously scanning old landing sites. In the high-resolution photographs, they spotted not just the Luna 17 lander, but the tiny, distinctive tracks of the Lunokhod rover itself. They followed the twin trails across the dusty plain, tracing a path that ended at a small, bright object. There it was, the long-lost rover, and with it the reflector. Its precise coordinates were now known with stunning accuracy. The recovery was more than just a historical footnote, it was a scientific resurrection. Researchers at the University of California, San Diego aimed a powerful laser at the newly found coordinates. To their amazement, they received a strong, clear signal back. The reflector, after 40 years of lunar night and day, cosmic radiation and dust, was not only found but was functioning perfectly, even better than some of the newer reflectors placed by Apollo missions. Why was its signal so unexpectedly strong? One theory suggests that the rover's final orientation left the reflector tilted in just the right way to more efficiently catch and return the laser pulses from Earth. This lost and found story transformed a Cold War artifact into a premier scientific instrument once more. Its dramatic recovery underscores a profound truth: on the Moon, even our own discarded tools can become sources of wonder and discovery, waiting silently in the dust for us to find our way back to them. Gassendi Crater is a magnet for the strange. This magnificent formation, over 100 miles wide, sits on the northern edge of the vast Mare Humorum. With its complex terraced walls and a central peak system fractured by a web of rills, it is a geologist's dream. But for anomaly hunters, it is something else entirely: a persistent hotspot where the moon's oddest behaviors seem to congregate. For centuries, observers have documented peculiar events within its confines. Most famously, in the mid-1960s, multiple astronomers independently reported a deep reddish glow emanating from the crater's floor, a phenomenon that lasted for several hours. This was not a brief flash, but a sustained colored luminescence that painted the gray terrain with an eerie, unnatural light. Others have recorded temporary obscurations where specific details inside Gassendi, a small craterlet or a ridgeline, would seem to blur or vanish entirely for a time, as if veiled by a localized thin mist. The sheer volume of these transient lunar phenomena reports from this single location has earned it a reputation as one of the moon's most active and enigmatic stages. The speculation intensifies with certain photographs. Some images, often taken under extreme lighting conditions, appear to show geometric shadows cast across the crater floor. Long, straight lines and angular shapes are discernible, shadows that do not seem to match the known, rounded topography of boulders or hills. To some analysts, these shadows suggest the presence of large, regular forms, what they cautiously term possible structures, though the scientific community overwhelmingly attributes these to the combined tricks of low sun angles, the brain's pattern seeking pareidolia, and the pixelated limitations of older photographic film. Yet the concentration is undeniable. Why here? One plausible theory points to Gassendi's geology as the ultimate trigger. Its floor is a fractured plane crisscrossed by those deep rills and grooves. These are not just surface features, they are likely conduits to a subsurface world of voids and cracks. If outgassing events are the source of many transient phenomena, then Gassendi, with its extensive network of faults, would be a natural release valve for trapped gases from the lunar interior. A sudden emission of radon or another gas could create a temporary, localized atmosphere that scatters sunlight, causing a reddish glow or blurring surface features. The geometric shadows could then be explained by the sharp, clean lines of the crater's own tectonic fractures, cast in impossibly long and distorted forms by the horizon grazing sunlight. So Gassendi stands as a perfect microcosm of the lunar mystery. It gathers the spectral glows, the vanishing acts, and the provocative shadows all into one breathtaking arena. It presents not a single puzzle, but a portfolio of the unexplained, forcing us to ask whether we are seeing the simple, if dramatic, geology of a broken world, or the subtle hints of something that still quietly defies our maps. Even our most advanced eyes on the moon can be fooled. The far side, a realm hidden from Earth, has become the stage for some of the most captivating modern mysteries captured by China's Chang missions. In late 2021, the Yutu-2 rover was methodically exploring the von Karman crater when its panoramic camera caught something startling on the northern horizon. There, silhouetted against the stark skyline, was a sharply geometric shape. It looked like a perfect cube, its edges appearing straight and its faces flat, sitting on the crater rim like a deliberately placed monolith. The internet erupted with speculation, dubbing it the moon cube or the mystery hut, drawing inevitable comparisons to the iconic monolith from the film 2001: A Space Odyssey. It seemed too precise, too angular to be natural. For months, it was a pixelated enigma, a symbol of the unknown waiting just over the next ridge. The rover team, understandably intrigued, directed Yutu-2 on a slow, careful trek to investigate. After weeks of painstaking travel, the rover finally closed the distance. The high-resolution images it sent back solved the mystery, but did not diminish the wonder. The cube was, in fact, a rock. Not just any rock, but a peculiarly angular boulder sitting atop a small crater rim, its sharp edges likely fractured by eons of thermal stress and micrometeorite impact. The play of light and shadow from a great distance, combined with the low resolution of the initial panoramic shot, had compressed this irregular stone into a near-perfect geometric illusion. This was not the rover's first encounter with such a trick. Earlier in its mission, U-22 had spotted another curious object, similarly dubbed a mystery hut or lunar cabin. That, too, upon closer approach, resolved into a solitary, somewhat lumpy rock. These episodes are profoundly instructive. They are not failures of technology, but revelations about perception. We sent a sophisticated, robotic explorer to a world no human has ever walked, equipped with cutting-edge instruments, and it still fell prey to the same ancient human instinct to see structure in randomness. The cube and the hut are 21st century versions of the lunar spires and bridges seen by astronomers of the past. They prove that no matter how clear our cameras become, the moon retains its power to present riddles. The mystery is never truly in the rock, but in that thrilling moment of first sight, when the distant and unknown briefly promises something more, reminding us that the urge to discover is always first an urge to wonder. The moon is not a silent world, it trembles. During the Apollo missions, astronauts left behind a network of seismometers that operated for years, painting a startling portrait of a geologically active neighbor. They recorded thousands of events, revealing a lunar interior alive with subtle, constant motion. These moonquakes fall into distinct and mysterious categories. The deepest originate over 500 miles below the surface, likely triggered by the gravitational tug of the Earth as it flexes the moon's rigid interior. But it is the shallow moonquakes that present the greater puzzle. These events are far more powerful than their deep counterparts, some registering up to 5.5 on the Richter scale. They originate only 20 to 30 miles down, and they produce a sharp, high frequency shaking very different from the long, rolling quakes we experience on Earth. Their cause remains an open question. One possibility is that they are tectonic in nature. The moon is slowly shrinking as its interior cools, causing the brittle crust to wrinkle and break along faults, generating these sudden, powerful slips. Another theory points to the accumulated stress from the incredible temperature swings, or perhaps even the lingering strain from ancient, giant impacts echoing through the crust. Yet none of these explanations perfectly fit the data, leaving the true trigger for these powerful, shallow tremors unresolved. Then there are the thermal moonquakes, a daily rhythm tied directly to the lunar extreme. As the Terminator line sweeps across the landscape, bringing brutal, sudden change from 260 degrees Fahrenheit in the sun to 280 degrees below zero in the shade, the very rock of the moon groans. The surface expands and contracts with such violence that it creates thousands of tiny, predictable quakes every lunar morning and evening. It is the sound of a world cracking under the strain of its own environment, a reminder that even without an atmosphere, the sun's light is a physical force that shapes and stresses the lunar crust with clockwork precision. So beneath that still, gray exterior lies a world of hidden vibration. A symphony of cracks, slips, and shudders that tells us our silent companion is, in its own quiet way, very much awake. The same electrostatic forces that may stir the dust could also solve one of the moon's most beautiful and ethereal mysteries witnessed by human eyes. As the Apollo astronauts orbited the lonely moon, they witnessed something profoundly unexpected during lunar sunrise. Just before the sun's edge breached the horizon, a bright, diffuse glow would appear, stretching along the Terminator line. It was not the gradual twilight we see on Earth caused by an atmosphere scattering sunlight. This was a sharp, luminous band hovering above the pitch-black surface, as if the ground itself was emitting light. The astronauts described it as a horizon glow, and it suggested the impossible, a layer of fine dust particles suspended high above the airless moon. This observation was so compelling that scientists designed a specific experiment for the Apollo 17 mission called the Lunar Ejector and Meteorites Experiment, or LEM. Its purpose was to detect tiny particles kicked up by meteorite impacts, but it returned data far stranger than anyone anticipated. the sensors began registering a storm of high-velocity particle impacts every lunar dawn and dusk, as if the sunrise itself was triggering a violent, horizontal blizzard of dust. The readings were so intense and unexpected that many scientists initially dismissed them as an instrument malfunction, perhaps caused by the experiment's own electronics overheating in the harsh sunlight. The LEAM was eventually turned off and its bizarre data filed away as an unsolved anomaly. Decades later, with new perspectives, researchers revisited those readings. A groundbreaking theory emerged. What if the experiment was actually working perfectly? What it detected might not be a malfunction, but the signature of an invisible, electrified dust storm. The mechanism is thought to be purely electrostatic. On the day side, solar ultraviolet radiation knocks electrons loose from the lunar soil, giving the dust grains a positive charge. On the night side, they are bombarded by electrons from the solar wind, gaining a negative charge. At the terminator, the dramatic boundary between day and night, these opposing charges create a powerful electric field. Dust particles resting on the surface could suddenly find themselves repelled by like charges and violently launched, leaping and skimming just meters above the ground in a silent, microscopic avalanche. This electrostatically levitated dust could create the horizon glow the astronauts saw, with sunlight scattering off countless billions of these hopping particles. It might also explain the LEAM's wild data, as those high-flying dust grains slammed into its sensors. Yet, the mystery is not fully settled. Some computer models suggest this process should create a permanent, low-lying dust atmosphere or exosphere, but other measurements have failed to detect it at the levels predicted. This leaves a haunting gap in our understanding. We have the eyewitness accounts, we have the controversial instrument data, and we have a compelling theory that fits the puzzle pieces together. But the definitive proof, the direct observation of these dawn dust storms in action, remains just out of reach. It means that on the moon, sunrise is not a quiet affair. It is a silent, electrifying event where the very ground stirs to life, launching invisible fountains of dust into the black sky, a daily resurrection hidden in plain sight. The horizon glow hinted at dust, but the moon's coldest shadows hold a far more precious secret. For most of human history, the moon was considered a bone-dry desert, its surface baked sterile by eons of unfiltered sunlight. The idea of water ice existing there seemed laughable, a scientific impossibility. Yet, a persistent mystery lingered around the poles, in craters so deep and steep-walled that sunlight has never, not once in billions of years, reached their floors. These are the permanently shadowed regions, the coldest known places in our entire solar system, with temperatures plummeting to nearly 400 degrees below 0 Fahrenheit. Within these abyssal black pits, a tantalizing question formed: could water ice, delivered by comet impacts over the ages, survive frozen in this eternal darkness? The detective work began in the 1990s. NASA Clementine mission, using a clever radar experiment, bounced signals into these shadowed craters at the South Pole. The reflections that came back had a signature that strongly suggested the presence of ice, a eureka, a moment that sent shockwaves through the planetary science community. The case grew stronger with India's pioneering Chandrayaan-1 mission in 2008. Its Moon Mineralogy Mapper instrument didn't just hint, it detected the definitive chemical fingerprint of water molecules, not in the shadows but surprisingly in sunlit areas as well, though bound within the soil. The polar shadows, however, were the vaults. The mystery demanded a more dramatic test. NASA L-Cross mission provided it. In 2009, the mission sent a spent rocket stage crashing at over 5,000 miles per hour into the permanently shadowed crater Cabeus at the South Pole. A following spacecraft flew through the resulting plume, analyzing the ejected material in real time. The results were stunning. The plume contained not just water, but a treasure trove of volatile compounds, including hydroxyl, carbon monoxide, methane, and even ammonia. The data revealed the water wasn't just a trace, it was abundant, with concentrations estimated at several percent by weight in the lunar soil within that crater. The long-standing anomaly was solved, the vaults were real and they were full. But as with any great discovery, it opened new mysteries. How is the water distributed? Is it in pure sheets of ice or mixed uniformly with the dirt? Where did it all come from? Comets, asteroids, or the solar wind itself interacting with the soil? Each robotic mission and every new orbital sensor adds pieces to this puzzle, revealing a moon that is not dry, but a dynamic, albeit frozen, water cycle in slow motion. This changes everything for our future. That ancient ice is no longer just a scientific curiosity. It is a potential resource offering life support, breathable air, rocket fuel, and a foothold for sustained exploration. The mystery of the shadowed ice has been answered, but its story is just beginning to be told. The water ice we find today is a visitor, but the very rock of the moon tells a story of a far more intimate connection. When Apollo astronauts brought back the first pristine samples of lunar material, scientists eagerly began to dissect their chemical secrets, expecting to find the signature of an alien world. What they discovered instead was a profound and puzzling familiarity. The rocks were not like those from Mars or the asteroids. In their precise isotopic compositions, the subtle fingerprints of elements like oxygen, titanium, and tungsten, the lunar samples were virtually identical to those found on Earth. This was and remains a staggering anomaly. Isotopes are different versions of the same element, distinguished by the number of neutrons in their atomic nuclei. The ratios of these isotopes form a unique signature for planetary bodies, a kind of cosmic DNA shaped by the conditions of their formation. For two separate worlds to share such a precise isotopic match is extraordinarily rare, suggesting they were forged from the same primordial material in the same corner of the solar system. This single, stubborn fact became the cornerstone of our modern understanding of the moon's origin, the giant impact hypothesis. The theory paints a catastrophic and beautiful picture. Early in the solar system's history, a Mars-sized protoplanet, which scientists have named Theia, collided with the infant Earth in a glancing blow of unimaginable violence. The impact was so titanic that it vaporized a significant portion of both bodies, launching a colossal cloud of molten rock and vaporized metal into orbit around our wounded planet. Over time, this swirling disk of debris coalesced, cooled, and solidified, giving birth to our moon. The isotopic match makes perfect sense under this model, because the material that formed the moon was predominantly sourced from the Earth's own mantle, and the obliterated Theia thoroughly mixed in the cosmic blender of that collision. Yet this elegant solution introduces its own deep mysteries. If the moon formed from a mixture of two different planetary bodies, why does it so overwhelmingly carry Earth's isotopic signature and not a more blended one? Sophisticated computer simulations of the impact show that the disk of material from which the moon coalesced should have been composed mostly of Theia, roughly 60 to 80%. If that were true, the moon's isotopic fingerprint should look much more like Theia's and less like Earth's, unless Theia just happened to have an isotopic composition almost identical to Earth's, a wild and statistically unlikely coincidence. This forces scientists to reconsider the mechanics of the impact itself. Perhaps the collision was even more violent and energetic than previously thought, leading to such thorough mixing and equilibration between the two bodies' materials that their isotopic identities became completely homogenized. Or maybe the impact scenario was different, involving a fast-spinning early Earth that was struck in a specific way. The isotopic anomaly, therefore, is not a closed case. It is the key that unlocked the door to the moon's violent birth, but it also guards the secret of exactly how that birth unfolded, challenging us to reimagine the most defining moment in our planet's early history. The violent birth that forged the moon's identity also forged its hidden heart, Deep beneath the craters and plains, our seismic instruments have mapped a core that is both surprising and strangely small. The data from those Apollo seismometers revealed a layered interior with a solid inner core and a fluid outer core, much like Earth's but on a dramatically reduced scale. Estimates suggest the entire metallic core is only about 300 miles across, roughly 20% of the Moon's total diameter. For comparison, Earth's core is over half the planet's width. This presents a profound thermal mystery. A small core cools quickly. The heat from formation and from radioactive decay should have bled away into space billions of years ago, solidifying the entire interior and shutting down any geological engine. Yet, the seismic whispers tell us the outer core is still molten, and the Moon's surface bears witness to volcanic eruptions that persisted for well over 1 billion years after its formation. How could such a small body retain so much heat for so long, fueling the vast lava seas that created the dark Maria we see today? The answer may lie in the Moon's unique chemistry. The rocks brought back by Apollo are rich in elements like potassium, rare earth elements, and phosphorus, collectively known as KREP. These elements are potent heat producers through radioactive decay. Scientists theorize that early in the Moon's history, this radioactive KREP material may have become concentrated in a thick, insulating layer surrounding the core like a thermal blanket. This blanket would have trapped the interior heat, slowing the cooling process and allowing the mantle to remain partially molten, feeding volcanoes for eons. The partially molten state of the core also has direct implications for one of our earlier magnetic mysteries. A molten, churning metallic core is what generates Earth's global magnetic field through a dynamo effect. The Moon's small, partially liquid core might have once been active enough to produce its own global magnetic field billions of years ago, a field whose last remnants we now see frozen into the crust as those isolated magnetic anomalies. So the size of the lunar core is not just a static measurement. It is the key to a thermal history that defies simple expectations, a story of a world that clung to its inner fire far longer than its size should have allowed, painting its face with dark plains and leaving behind magnetic ghosts as the final embers of that great heat faded into the cold of space. That lingering heat from a small core has a distinct chemical signature, one that is not spread evenly across the Moon. It is concentrated in a vast, geochemically unique province known as the Procellarum Creep Terrane. This enormous region, centered on the Ocean of Storms, or Oceanus Procellarum, is the Moon's most dramatic geological anomaly. Here, the crust is enriched with those strange, heat-producing elements, potassium, rare earth elements, and phosphorus, which scientists collectively call creep. These are not your average lunar rocks. They represent the final, dense dregs of the global magma ocean that once covered the entire Moon. Think of it like this. In the Moon's earliest days after its violent formation, its entire outer layer was a deep, churning sea of molten rock. As this global ocean began to cool, crystals started to form and sink. Lighter minerals floated to the top to form the primordial crust, while heavier elements like iron sank toward the core, but the creep elements were chemically sticky. They did not easily fit into the crystal structures of the common minerals. Instead, they were left behind, becoming increasingly concentrated in the last remaining slivers of magma, a thick, radioactive, and dense chemical soup. This final melt was the last thing to solidify. Now, why is all of this potent material seemingly pooled on just one side of the Moon, primarily in the Procellarum Basin? This is the heart of the mystery. The leading theory is that this concentration was not an accident, but a direct consequence of a cataclysm. The colossal impact that created the immense Procellarum Basin, one of the largest in the solar system, may have punctured the young lunar crust. This catastrophic event could have effectively tapped into and unleashed this deep reservoir of creep-rich magma, flooding the newly formed basin with the last remnants of the magma ocean. It is as if the impact uncorked a bottle, allowing the moon's final, fiery breath to spill out over a single, vast region. This geochemical lopsidedness helps explain the moon's asymmetric volcanic history. The Procellarum creep terrain, acting as a giant, natural radioactive heat blanket, kept the mantle beneath it warm and partially molten for far longer than anywhere else. This sustained heat engine is why nearly all of the moon's great volcanic plains, the dark maria we see from Earth, are located on the near side, flooding from this one anomalously hot spot. For future explorers, this terrain is more than a scientific curiosity. It is a potential treasure trove. Rare Earth elements are critical for modern technology, used in everything from smartphones and electric vehicles to advanced optics and guidance systems. A region naturally enriched with these materials could one day be a key resource for a sustainable lunar economy, turning a geological anomaly into a practical cornerstone for humanity's expansion into the solar system. This profound chemical lopsidedness leads us to the moon's ultimate, overarching mystery, the stark division of its very face. Our celestial companion is a world of two halves, a dichotomy so fundamental it shapes everything we see from Earth. The side that eternally faces us, the near side, is a familiar tapestry of dark, smooth plains, the Maria interrupted by brighter highlands, but turn the moon around and the character changes completely. The far side, hidden from view until the space age, is a battered, ancient landscape. It is almost entirely covered in bright, heavily cratered highlands, with only a few tiny patches of dark mare basalt. It is more rugged, with a thicker crust and higher elevation, a fossilized record of the solar system's most violent era. Why would one side of the same world look so utterly different from the other? This is not a minor curiosity, it is the moon's most fundamental anomaly. One compelling theory points to a colossal, ancient wound. The South Pole Aitken Basin on the far side is the largest, deepest impact crater in our entire solar system, over 1,500 miles across. The cataclysm that created it, over 4 billion years ago, may have been so violent that it sent seismic shockwaves rippling through the entire moon, thinning the crust on the opposite side, the near side. This catastrophic remodeling could have created a weak spot, a zone where later magma from the mantle could more easily erupt and flood the surface, creating the great dark plains we see today. Another idea focuses on internal heat. Early in its history, the moon was much closer to Earth, and our planet's fierce gravitational pull stretched and flexed its interior through tidal forces. This friction generated heat, but that heating may not have been symmetrical. If the moon's interior composition or structure was uneven, perhaps due to that giant impact, the tidal heating could have been concentrated on one hemisphere, keeping the mantle there warmer and more prone to volcanic eruptions for billions of years. This connects directly to the Procellarum creep terrain. That radioactive hotspot on the near side could be both a cause and a consequence of this asymmetry. The simplest explanation may be a difference in armor. Evidence suggests the far side's crust is significantly thicker than the near side's. A thicker crust acts as a stronger shield, making it harder for molten rock from the mantle below to punch through to the surface. On the near side, with its thinner crust, the same magma found an easier path, flooding out to create the seas of basalt. Yet, this just pushes the question back. Why was the crust thicker on one side to begin with? Was it the result of that far side mega impact, or did the debris from the moon's own formation simply accrete unevenly? The truth is, no single theory has yet won universal acceptance. Each has strengths, but also gaps that the others try to fill. The two-faced moon stands as the culmination of all its mysteries, a global puzzle where geology, chemistry, and celestial violence intersect. It reminds us that the most familiar object in our night sky is still, in its deepest nature, an alien world. One half forever turned toward us in silent companionship, the other forever turned away, guarding the scars of a history we are only beginning to read. This geochemical hotspot may hold the ultimate key to the Moon's divided face. The Procellarum creep terrane is not just a random patch of unusual rock. It is likely the primary architect of the most fundamental difference between the two hemispheres. The hypothesis is both elegant and powerful. That concentrated reservoir of radioactive elements like potassium and uranium acted as a long-lasting nuclear furnace, embedded directly beneath the Moon's near-side crust. For billions of years, this subterranean heat blanket did more than just keep the mantle warm. It fundamentally altered the physical properties of the crust above it. Intense, prolonged heating from below can make rock more pliable and weak. It can cause the crust to stretch thin and even sink under its own weight over geologic time. This process, known as thermal erosion, essentially cooked and softened the lunar crust in that vast region. The result was a critical vulnerability. When the Moon's interior was still hot and magma sought a path to the surface, it found the greatest resistance on the far side, where the crust was thick, cold, and strong. But on the near side, above that simmering creep terrane, the crust had been pre-weakened. It was thinner and more fractured, offering a network of ready-made escape routes for the molten rock. Think of it like the difference between trying to poke a hole through a thick sheet of ice versus a thin, warm layer of wax. The magma exploited this weakness on a planetary scale. Vast upwellings of basalt generated by the heat of the radioactive elements themselves found it comparatively easy to breach the surface. They did not create gentle volcanoes but apocalyptic floods. These floods of lava were so immense they could fill entire impact basins, creating the dark, smooth seas that dominate our view of the Moon. Oceanus procellarum, mare imbrium, mare tranquillitatis. These are not random features. They are the direct consequence of that buried radioactive engine weakening the crust and then erupting through it. Meanwhile, the far side, lacking this concentrated internal heat source, remained geologically stubborn. Its thicker, colder crust acted as a formidable lid, trapping most of the magma below. Only the most catastrophic impacts could occasionally puncture through to create the far side's few small maria. So the stark visual contrast we see today, the familiar face of dark seas and the hidden face of bright, cratered highlands, is not a coincidence of impacts. It is the surface expression of a deep, internal chemical imbalance. One half of the Moon was geologically blessed, or perhaps cursed, with a buried treasure of heat-producing elements, and that treasure reshaped its entire destiny, painting one hemisphere in darkness while leaving the other frozen in ancient light. The Moon's two faces are a riddle written in rock, and we are finally sending new detectives to read it. The next wave of lunar exploration is not just about returning to the surface, it is about targeting the very heart of this global anomaly. Ambitious missions from NASA, China, and other spacefaring nations are setting their sights on the most enigmatic regions, particularly the far side and the colossal South Pole Aitken Basin. NASA Artemis program, with its goal of establishing a sustainable human presence, will focus heavily on the lunar South Pole. While the pole itself is on the far side's edge, the science conducted there will probe the deep crust and the distribution of volatile materials, offering clues about the ancient processes that shaped the entire Moon. More directly, robotic missions are being designed to venture into the South Pole Aitken Basin itself. This giant scar, over 1,500 miles wide, is a natural drill hole into the lunar interior. By landing within it, future rovers could analyze material from the lower crust and possibly even the upper mantle, material that was excavated and thrown to the surface by that primordial impact. Studying its composition is like reading a page from the Moon's deepest geological history, one that could tell us exactly how the crust differs between the two hemispheres. Simultaneously, Chinese missions under the Chang program are pioneering the exploration of the far side. Following the success of Chang 4 and the Yutu-2 rover, future missions plan to return samples from this ancient, untouched terrain. Comparing farside soil and rock directly with the well-studied nearside samples from Apollo would provide the definitive chemical test. We could measure the precise thickness of the crust there, map the distribution of heat-producing elements, and finally see if the farside truly lacks that radioactive creep engine that fueled the nearside's volcanic fires. The data from these missions will be pieces of a grand puzzle. By understanding the asymmetry in crustal thickness, internal heat, and chemical makeup, we are not just solving a lunar mystery. We are testing our fundamental models of how terrestrial planets form and evolve after catastrophic collisions. Did the giant impact that created the South Pole Aitken Basin really thin the crust on the opposite side? Was the Moon's material always lopsided from its violent birth with Earth? Each new measurement brings us closer to an answer. Solving the mystery of the lunar dichotomy would do more than fill a textbook chapter. It would rewrite the opening pages of our own planet's story, revealing the precise conditions of that ancient impact that gave us our companion in the sky. The Moon's two faces have watched over Earth for eons, and now at last we are learning to look back and truly see them. These 25 lunar anomalies form a spectrum of wonder, from the ghostly flicker of a transient light to the deep, fundamental riddle of a world with two different faces. They are not merely a list of unsolved puzzles, they are a living curriculum for curiosity. Each unexplained flash, each magnetic ghost, each chemical imbalance pushes science forward, forcing us to build better instruments, devise more creative theories, and ultimately to go back and look closer. The Moon's mysteries are not walls, they are doors. They are the reason we map its gravity with exquisite precision, why we train telescopes on its darkest craters, and why nations are racing to send new rovers, landers, and even humans to its soil. Every anomaly is an invitation to explore, so the next time you step outside and see that familiar silver disk hanging in the night, see it anew. See the swirling patterns on its plains, remember the tremors in its depths, and ponder the ancient ice in its eternal shadows. That is not just a rock, it is an archive, a laboratory, and a neighbor still full of secrets. Which of these 25 mysteries captures your imagination the most? Was it the drifting lunar wave, the impossible geometry of the Blair Cuspids, or the profound mystery of its two-faced surface? Let us know your thoughts in the comments below. And if you enjoyed this journey into the unknown, be sure to subscribe. Our next deep dive into space mysteries is already